Okay, Assalamu alaikum. Welcome to the second lecture in the series. Now in this particular case we're going to discuss really a foundational principle which is called conditional probability, which some of you might be aware of because this course does assume some prior knowledge in probability. Hence, so I'm going to use an example this time of a real-time example of Lollywood. So Lollywood is the Pakistani version of Hollywood, and what we have done here, the data set that you see on the left hand side is basically 1, 2, 3, 4, 5 Lollywood movies, Khuda Ke Liye, Tifa in Trouble, Yalgar, Teen Bahadur and Allah Yaar, whereas on the columns each represent a particular actor or actress that participated in that movie. On the right column here is what is referred to as your classification problem, and in the sense this is Lux style awards. So these are the awards which are currently showcasing the cinema industry of Pakistan, where a 1 means it was either nominated or won an Lux style award. So it is nominated or won. Whereas a 0 represents it wasn't nominated or it didn't win the Lux style award. A word of caution, these are not exact in the sense that I haven't really seen most of these movies. I don't know how many people really acted in Yalgar, but this is just as a representation to serve as an example. These values do not represent true values, but they are somewhat of a representation to explain you the principle and the application of this particular subject. So where 1 represents, here a 1 represents this gentleman Shan was part of Khuda Ke Liye, the movie, or 0 represents this gentleman was not part of this movie. 1 represents that this movie either won the award or was nominated for a particular award. So as a production company, your primary aim is to choose the best team that can win us an award. Obviously, being either nominated or winning an award, you could assume is a good representation of a hit movie, a movie that generates a lot of revenue. So as a production company, you want to produce a hit movie, and by a hit movie I mean a movie that either wins a Lux Style award or is nominated to one, and they ask you to determine what is the best team of actors or actresses that can lead us to that role, because one has to understand within movies one particular aspect which is extremely important is the actor or the actress plays a huge role in drawing the necessary crowd. Hence, the important and you have to drive that solution using a data-driven science. So what you're going to do here is you're going to determine the likelihood, what is the likelihood, the word is what is the likelihood, and let's say you have to choose the leading actor. Now there are 2 actors here, one is Shan and one is Ali Zafar. So your question is, what is the likelihood of getting a hit, movie given, now this is the important word here, given an actor A is acting in it. So whenever the word likelihood comes in, whenever this word comes in, this word has directly to do with probabilities. So this statement here can be formulated mathematically as the probability of getting a hit, getting a Lux Style award, given, I'm going to use now as an example, Shan acted in the movie. What is the likelihood of getting a hit given Shan acted in the movie? Now, this particular, and you have to compare this with the probability of getting a hit given Ali Zafar acted in the movie. Now if the probability of this is larger, if this is greater than this, you're going to choose Sean. But if this probability is greater than this, then you're going to choose Ali Zafar. So this would go for Ali Zafar, whereas this would go for Sean. Okay? And hence this really shows your classification problem, where if this is greater than this, you choose Sean, whereas this is greater than this, you choose Ali Zafar. Now if I'm going to just choose this, and in the next lecture we are going to expand this to naive Bayes classifier, but if I'm going to just look at these two, what I have here is what is referred to as a conditional probability. That what is the probability of getting a hit conditioned upon Sean acting in the movie. This is called conditional probability. Now the general framework of conditional probability is probability of A given B. The general formulation is probability of A intersection B divided by probability of B. Now rewriting, this is the general formula. Now rewriting this in terms of this, I get something like probability of a hit given Sean is equal to probability of hit intersection Sean divided by probability of Sean. If I look at the denominator, then the probability of Sean really is the total number of events here. That would be the total number of movies, all the movies, and then the number of movies in which Sean acted. So if I just count here, there are 1, 2, 3, 4, 5 movies in this example. Obviously an entire data set would have hundreds of movies in there. So these are the total number of movies, whereas the number of movies where Sean was acted was, you just count the number of ones. So 1, 2, 3. So the probability of Sean comes out to be 3 over 5. By a similar token, we can determine the probability of Ali Zafar here. Probability of Ali Zafar. He acted in 1, 2 movies and the total number of movies are 5, so it is 2 over 5. Now, looking at the numerator, which is the probability, I can rub this part off. So the probability of getting a hit movie and Sean is in fact the number of movies which were hit. So these are again the total number of movies, this is again the total number of movies. And this is the number of movies which are hit and contained Sean. So the total number of movies are 5, because 1, 2, 3, 4, 5 in this example, whereas the number of movies which are hit and contain Sean, so now I'm going to see, okay, this is a hit and it contains Sean, so that's 1. This is a hit and it contains Sean, so that's number 2. And this is a hit and it contains Sean, so that's number 3. So 3 over 5. But let's just quickly do the same for Ali Zafar. So the probability that, now I'm going to use the black pen, the probability of having a hit and Ali Zafar in it is number of hit movies which contained Ali Zafar divided by the total number of movies. The total number of movies are still 5, where the number of movies that were hit, so that's 1, and contained Ali Zafar, so that did not contain it. So although this is a hit, this does not contain Ali Zafar, so I'm not going to count it. This is a hit and it contained Ali Zafar, so I'm going to count that as a 1. This is a hit but it did not contain Ali Zafar, so we just have 1. So 1 over 5. So going back to this formula, so probability of a hit given Sean is this guy, the numerator. From the numerator, we have this here, 3 over 5. I'm going to put that here, 3 over 5 divided by probability of Sean, which is 3 over 5, which is equal to 1. Now again, these are not exact values, but they do help to serve an example. Whereas if I'm going to compare this with the probability of a hit given Ali Zafar, probability of hit given Ali Zafar, so that's this guy divided by this guy. So that's 1 over 5 divided by 2 over 5, that's 1 over 2. So so this is how you calculate conditional probabilities given these examples. So I'm going to drop this off and write just here the value. So having calculated these values, I can just drop this part off for now. Having calculated this value, I can see this is 1 and this comes greater than 1 over 2. So hence you're going, because this is 1 and this is larger than 2, larger than 0.5, you're going to choose Sean as your main actor. So, you know, those probabilities that you learned and they didn't seem very useful then, this particular course will make you realize, no, they are extremely useful. And so, but the whole idea is, well, that's just an oversimplification of the problem. Because it's not just about the leading role. It is one of the leading role, obviously has a huge part to it, but there's an entire team of actors which, you know, determine whether a movie is successful or is not successful, and we shouldn't be counting these individually. We should be looking at the cumulative combined effect. So now the question is expanded, and the question really comes out to be, okay, how about, what is the likelihood of getting a hit given Sean and Rima were part of it? Now compare that with the likelihood of getting a hit given Ali Zafar and Mehwish Hayat are part of it. Again, you're going to choose this. So if this is larger than this, then you choose Sean and Rima. Whereas if Ali Zafar and if this value is larger than this, then the classification rule really boils down to this. So if you have to compare something like this, then what do? Well, this is a point where, because you have multiple conditions appended to it, we're going to first solve this using an easier way, which is called the naive Bayes classifier. We're going to first discuss this, and then we're going to talk about the exact way of determining this. Okay? So that's it. That's much for now. Thank you very much. See you again.